Hey everyone, let's jump into section 1.5 and do some function arithmetic. Hope everybody is having a good morning, or actually I don't know what time of day you're watching this. It's morning for me. So we are in 1.5 now. Function arithmetic. And basically what we're going to do is we are going to add, subtract, multiply, and divide functions. And the nice thing about this is all of the arithmetic, all of the operations work exactly the way that you want them to. So I'm going to write out the different, I guess you could call them formulas, but as I said, they work exactly the way you want, so you might never use this. And then we'll just do a couple examples. Okay, so we have the addition rule, and this says that if you have f plus g of x, so if you are adding the functions together, f plus g of x, this is just taking f of x plus g of x. If you are looking at the subtraction rule, so that would look like f minus g of x. Well, again, the subtraction works exactly the way you want it to. This is going to be f of x minus g of x. Now you just have to make sure that on that minus g of x part that you distribute through, and we'll see an example of that. Then we have the product rule. And this one looks like if you have f times g of x, well, this is f of x times g of x. So you can multiply two functions together, okay? And then finally, we've got the quotient rule. And the quotient rule says if you've got f divided by g of x, this is f of x divided by g of x. And then there's only one issue in the quotient rule, in the division. We just have to make sure that g of x is not equal to 0, because the division won't work if we've got that 0 in the denominator. But otherwise, like I said, it works just the way you want it to. So really what we're getting used to is seeing the notation f plus g, f minus g, f times g, and f divided by g. So that's the notation that we've got going on there. So like I said, let me give you an example here. Let's say that I had f of x equals 2x. Oh wait, 2x is kind of my go-to, but whatever. 2x minus 1. G of x will be equal to the square root of x plus 3. And we're going to put an h of x up here, and h of x is going to be equal to x squared minus x plus, I'm going to have to use my brain here for a moment. Let's just go plus 2. No, let's see. That won't work. Minus 2. There. Sorry about that. Okay. So I'm giving you 3 functions here so we can kind of mix and match. So what you might see for a problem, it might say find, and then it says f plus h of x. And what it's asking you to do is basically add this function and this function over here. So we could rewrite this if we want, like f of x plus h of x. But if you're like, no, I don't need to write that step, I want to skip that step, I don't need to see it. It's just there to help you. So we'll say 2x minus 1, and then we're going to add this guy, x squared
minus x minus 2. And whenever we're doing this function arithmetic, we don't want to leave the answer looking like this mess, okay? So we will simplify here and rewrite it. So I'm gonna write the x squared first, and then we have 2x minus x, which will give us a positive x, and then that's gonna be minus 3. Okay, so give it a little simplification. Now, if I asked you for f plus h of 2, well, we could go directly back to f and h, but didn't we just figure out what f plus h is? So we could take that 2 and we can plug it. Remember, it's not multiplication, it's telling you to substitute in. We could substitute in that 2 right into the formula. So we'll also go 2 squared plus 2 minus 3. All right, so we got 4, 6, minus 3 is 3. Now, they might also ask you just to do something like this. F times g of 4. Okay, so this first one I put an x in there. This one they're just going directly to f times g and then of 4. So they want us to plug in 4 into both of these functions, but we're multiplying. So if we write it as f of 4 times g of 4, we're going to plug 4 into here, and then we're going to plug 4 into here. So we'll go 2 times 4, minus 1, times, and then we'll put the 4 underneath the square root of 4 plus 3. All right, so the f of 4 gives us 2 times 4 is 8, minus 1, so 7 times, and the square root of 4 is 2 plus 3 more is 5. So what it's asking us to do is actually go 7 times 5, and that will give us 35. So the idea is just making sure that we're plugging things in the right function and that we're doing the correct operation. All right, so let me give you another one real quick. Again, hopefully these are very straightforward to you, so you don't mind if I erase them. But hopefully you also have them in your notes. But let's say this time I want you to find f over h. And they might just give you this. I don't know why they do this. This is just kind of, oh, I do. Mathematicians are lazy people. So if we can not write something, we won't write it. So if they just give you the notation f over h, what they're asking you to do is to figure out what that function is, and what really should be here but is missing is the of x. So they're not asking you to plug in any numbers, they're just asking you to find f of x over h of x. So all we're doing is plugging those two functions into this little fraction. So we're just going to take 2x minus 1 up top, and then move over to the h. We're going to go x squared minus x minus 2. And there we've got, I mean, that's what they wanted us to do. We're just are going to plug in. But when it comes to the division, if you remember down here, I erased it, there was something we had to make a note of. We have to make sure this denominator is not equal to 0, and so we need to tell people what would be a problem here. So whenever you're doing the division one, remember about the denominator. So we need to figure out where x squared minus x minus 2 equals 0. And again, this is a quadratic, so we're looking at a factoring problem. So if we factor this guy, well, x is up front, and we need a negative x in the middle, but a negative 2. So that's going to be 2 and 1. And this guy will be negative, and that guy will be positive, right? So negative 2 plus 1 gets us our negative x. So that means x is equal to either 2 or -1. But those are the guys that we don't want. So you can either put a line through it there, or we can just say x can't equal 2 or -1. So where 2 or -1 would have been fine, like 2 was fine right here, okay? Would have been fine if we were doing any of the other operations. When it comes to the division operation, we've got to make sure that we note to people it can't be 2 or -1. Those guys will cause a problem. Okay, so should again be pretty straightforward here, but what we're going to do is we're going to bump it up a little bit, and we're going to look at something that we will use like for the first month and a half when you get to calculus. You're going to use this every single day over and over and over again. So it fits into this section, even though we're not going to do the calculus part of it, we're going to do the function arithmetic part of it. But this is what you're going to see when you head to calculus, and it's called the difference quotient. And the difference quotient looks like this: f of x plus h minus f of x divided by h. Now at this point you may be thinking, why the heck are we doing that? Why do we care? But I promise once you get to calculus this will make sense. So they're going to give you a function and they're going to ask you to find the difference quotient. So let's start with, we'll start easy and then we'll go more difficult. Let's say that f of x is equal to -4x minus 1. And they're asking us to find this difference quotient. Now in the difference quotient, we need f of x, which luckily we have, but what we need to find is this f of x plus h. Now here's the deal. This is plugging in, so if you remember from 1.4's lecture, this means that we're plugging x plus h into the function. So we're going to find f of x plus h, which means wherever we see that x, we're going to put x plus h. All right, so we'll multiply out there, so we'll have -4x minus 4h minus 1. Now, nothing is really going to get pretty here until we start putting the whole thing together. So it's going to be ugly, and then it'll start to get better and better. So if we want the difference quotient, which we'll just call DQ, which reminds me of Dairy Queen, so now I want some ice cream. Okay, so we're going to take this guy and then subtract the original. So we're just going to write down just what we found: -4x minus 4h minus 1 minus, and then in parentheses, we're going to put this guy, minus 4x minus 1, all over h. And now again, we're not going to leave it like this, we're going to simplify. So we want to see what we can do here. Now, this minus comes in here and comes in here, doesn't it? So it's a minus 4x plus 4x. So those guys actually cancel out. Okay, that's nice. And now that guy doesn't do anything, but we have a minus 1 and then minus a minus, so plus 1. So the 1's actually go away. So in the end, up top, all we actually have is -4h, right? Everything else went away. And on the bottom, we have just h. And now one more step, right? We can go boop, boop. And so in the end, this difference quotient actually simplifies way, way down, all the way to -4. Now, the difference quotient will not always simplify down that much, but in this case, we kind of luck out, okay? So let me show you another one that's a bit on the uglier and bigger side, even though it might not seem that way to start with. Let's say that I told you that f of x was equal to the square root of x. Okay, I want you to find the difference quotient. So we already have the f of x, and we need to find the f of x plus h. Now at first this doesn't look so bad. We're just gonna plug x plus h underneath the square root. There isn't any simplifying we can do, so it's actually looking better than this. But now we set up that difference quotient, and that's where kind of all hell breaks loose, okay? So we're gonna start with this guy, the square root of x plus h minus the original. All over h. Okie dokie. Now, honestly, it doesn't look that bad, but when we're dealing with the difference quotients, here's the thing. We want to get it, let's say, as simple as possible. Okay, we want to simplify this as much as possible. And even though it looks simple, it has these two square roots in it, which really are not all that simple. So we want to get rid of the square roots, or we're going to rationalize the numerator. And it's gonna look uglier when we're done, but this is what we're gonna do. So in order to get rid of square roots, we multiply by the conjugate. Multiply by the conjugate. And the conjugate is just the same thing, but switching the sign here. So it's gonna be the square root of x plus h plus the square root of x. But if we do that to the top, we also have to do it to the bottom. So on the bottom, we're gonna have the square root of x plus h plus the square root of x. So you see where I'm going with about how this is getting uglier and uglier? All right, so up top, we need to FOIL that guy out. But it's gonna work nice because we've created it to work nice. The square root of x plus h times the square root of x plus h, the square roots will cancel out, and we'll just be left with x plus h. And basically what we're looking at here is if we go x plus h squared, right? Two of them, x plus h times x plus h, they go boop, boop, and that's how we just get the x plus h. Now, because we changed the signs in the middle, that means that this term here and this term here are going to cancel out. So the middle term disappears entirely. And then at the end, we've got the square root of x times the square root of x. So that's going to leave us minus x. So that top part is going to simplify quite a bit. No more square roots in it. Now the bottom did not get any prettier though. We still have h, and we still have the x plus h, or sorry, square root of x plus h plus the square root of x. Now notice that I didn't distribute through. The reason why is because I can kind of know where we're headed. So don't do your distribution yet. Now let's look up top. What do we have here? X minus x means that those two guys go away. Nice. So all that's left up top is the h, and now we still have this whole mess on the bottom. But what else can happen, right? We got the h's that disappear, fantastic. Now when the h goes, there's still a 1 up top, and now the bottom of our fraction looks like the square root of x plus h plus the square root of x. And I know you might say to yourself, I don't understand why that is any better than what we started with originally. But when it comes to the calculus that we're going to learn later, or you're going to learn later, this guy is a lot better. And the key here is that I want you to notice in both of these guys, after some simplifying, do you notice how the h's canceled out? We did a lot of work here, ugly, 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 but look at what happened at this step. These h's canceled out. Now we still have something ugly in the denominator, but that h and that h canceled out. And ideally, when you do the difference quotient, that is what you're going for. You want for the h to cancel out. Whatever's left over is left over, but the h canceling out is the important part, okay? All right, so function arithmetic. addition, subtraction, multiplication, division, and then they're gonna throw some difference quotients at you, okay? Other thing about this, there is a word problem in 1.5 that is all about economics. If you are thinking you're headed towards business calc or you've taken business classes, you will want to do that economics example. If you are not looking at economics or business as your area of expertise, you're going, you know, to regular calculus and the whole science realm, do not worry about doing that problem. If it doesn't make sense to you, it's really okay. Okay, so yeah, you can skip the economics problem in the practice homework if you want. I won't ever test you on that. Oh, okie dokie. There you go. All right, see you next time.